Aufbau'S Principle. If we are talking about filling electrons in their respective orbitals, you can't talk about that without referring to this man called Aufbau. He's the one that proposed that electrons will enter into the lowest energy level before the next higher one. That is to say that electrons will go into that energy level which has the lowest energy before proceeding to the next higher one. That is when you are filling electrons inside the respective orbitals, consider that one that has lowest energy level. That is the one that the electrons will go into first before now they start filling up the other higher ones. Let us see the sequence involved in Aufbau'S principle. Don't forget that this Aufbau principle is applicable to the subshell of an atom, that is S, P, D, and the F. This is the sequence in Aufbau'S principle. We are following the arrow. That is to say that after one x is filled up, we take 2s. Just follow the arrow here. After one s, we take 2s. After 2s, we take 2p. 2p. After that, now we have 3s. After 3s, now there's nothing down here. Then you come up here. 3p. After 3p, now you see 4s there. You take 4s. After 4s, there's something down here now. So you come to 3 what? D. After 3D, now you have 4p. You have 5s, etc. We are just following the arrow. After we pick this one, we pick this one, pick here, pick this one, this one, this one, just like that. We are following the arrow. We are not maintaining a straight line, no, but we are following the arrow. You see, the arrow is pointing down, so that's how you pick your numbers. 1s, there's something else there. You come here and pick 2s, there's something here. 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 3, 5p, 6s, nothing down here, 4f, 5g, 6p, and the 7s. And so many of them. We didn't write them all. So many of them. So that is the sequence. In essence, it means that electrons, this one has the lowest energy level, followed by this one, just like that. And that is how the electrons will enter into these subshells by following this rule, Aufbau's rule. That is to say, but remember that this is just a guide for us to know how to write electronic structure of an element in the subshell. Subshell, I mean S, P, D, and F. But before then, there are some points you need to note before you proceed to write the electronic structures of an atom. Such points like S subshell can take a maximum of 2 electrons to be filled. Anywhere you see S, it can only take 2 electrons to be filled. If you listen to me very well, I said S subshell can take a maximum number of 2 electrons. That is to say that S can still take one, but it cannot take more than 2. That is a maximum of 2 electrons. Anywhere you see P subshell takes 6 electrons to be filled. 6 electrons, maximum of 6 electrons. That is to say that P can take 1, can take 2, 3, 4, 5, 6. It cannot take more than 6 to be filled. Just as we have D subshell can take 10 electrons to be filled. 10 electrons to be filled, while F subshell takes 14 electrons to be filled. So these are the points you need to take note of. S can take 2 electrons to be filled. P can take 6 electrons to be filled. D can take 10 electrons to be filled. Maximum of all these numbers I'm calling is the maximum number. That is to say that they cannot exceed that number stated here. It cannot exceed this number. Okay, now having understood these rules, let us now forge ahead to write, to apply all these things we have learned now, to write the correct structure of an element. That is the correct electronic structure of an element using SPDF. Don't forget that SPDF is the subshell of an atom, where S means sharp. These are the lines of spectra of hydrogen. S means sharp, P principle, D diffuse, F is fundamental. These are lines of spectra in the hydrogen or hydrogen spectrum. These are the lines you see when hydrogen is passed through a spectrum. So let us consider examples of how we can apply these rules to write the electronic structures of elements. The question is write the electronic structures of the following elements on the board. You see calcium, sodium, chlorine, and the rest of them. So let us consider the number one, calcium. I always tell students that your failure starts when you don't know your first 20 elements, at least at this level. So if you don't know that calcium has 20 electrons as well as 20 protons, you have started failing. That is to say that the atomic number of calcium is 20. So when you are asked to write the electronic configuration of a calcium using the SPDF notation, don't forget all we have learned here. Follow the sequence. Follow the sequence. So, and anywhere you see X, you know that it takes a maximum of how many electrons? Two. We are considering 20 electrons. So 1s2, 2s2. Remember, S takes, anywhere you see S, it takes a maximum of 2 electrons to be filled. After that, I have 2p6, 3s2. Remember, these things you are putting on top, they are the number of electrons. So if you are adding, you'll be calculating whether it is up to 20. Don't forget the sequence. After 1s, we pick 2s. After 2s, 2p. After 2p, 3s. Just as I'm writing here. After 3s now, 3p. 3p, 6. Let us count. 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. 12 plus 6, 18. That means we need extra 2 electrons to complete this. After 3p, we are going to get what? 4s. And it's supposed to be 4s what? 2. This is the electronic structure of calcium using SPDF notation. Let us check that of sodium. Sodium is 11, 1s2, 2s2, 2p6. Don't forget the sequence. 1s, 2s, 2p, 3s, 3p, 4s, 3d, and so on and so forth. Just master this sequence. That is your key to understanding this. After 2p, now we get to 3s. But before then, you count. We are looking at 11. 2. 2 plus 2, 4. 4 plus 6, 10. So the next one is what? 3s1. That brings me to that thing I told you that S takes a maximum of 2 electrons to be filled. Doesn't mean that it cannot take 1. If you understand the English, maximum, that is the highest number it can take, is 2, which means it can take 1. Just like P subshell, it takes 6, maximum of 6 electrons to be filled. Doesn't mean it cannot take 1. Remember, the number you are putting there depends on the number of electrons you are looking at. Assuming that we go by the rule, S takes 2 electrons to be filled. If we put 2 here, we are writing another element, not that one we are told to write. So if you mistakenly put 2 here, because you know that X takes 2 electrons to be filled, which means if you add up this, it will be magnesium, and you have found why you were told to write that of sodium, which is 11. So be careful. If you are adding the numbers, be counting so that you know when you get to that particular number you are looking for. Okay, let us see chlorine. Chlorine, atomic number of chlorine is 17. Hope you know that. So let us go 1s2, 2s2. Remember, after 2s, 2, 2p, 6. 3s2. I'm going to count 2 plus 2, 4. 4 plus 6, 10 plus 2, 12. 3p what? 5. 3p 5. If you count this thing now, it is 17. If you count this number on top, 2, 6, 2, 2, 6, 2, and 5. It is 17. That brings us again to this. If you mistakenly, because of the fact that you know that P takes 6 electrons, and you put 3p6, you are writing for another element, and you have found it. Yes, P can take 6. I am repeating this thing all over. P can take 6 maximum, but it can take 1, can take 2, can take 5, depending on the number of electrons you are looking for. Hope you are getting it. Now, magnesium. Don't forget, if you fail to know the atomic number, that is the beginning of your failure. If you forget the atomic number of any element, you have started failing already. Magnesium, 1s2, 2s2, 2p6, 3s what? 2. Count it, it is 12. 2, 6, 2, 2 is 12. That is for magnesium. And now lastly, silicon, I believe is 14, atomic number. So if you watch it now, 1s2, 2s2, 2p6, 3s2, that is 12. 4, 6, 12. And the 3p what? 2, making it 14. Have you seen this scenario? P has taken 2. But have you seen me writing maybe 3p7? It is a jargon. P cannot take more than 6. Have you seen me writing maybe 1s3? It is jargon. X can take 2 to be filled. It cannot take more than 2. So if you consider all these things, you can as well give yourself an assignment to do. We are looking at another dimension of this one. See you in the next video.